today. But in the meantime, I wanted to finish up this discussion we talked last time, and this may probably go for most of it. It may go for all of the session. We'll have to see. And this has to do with requirements. I tried to motivate in the closing minutes of last lecture. I tried to motivate the discussion of requirements. Can anyone remind me, why did I argue that? On what basis did I argue that they were important? Anyone? Why are requirements so important?
They help streamline the process.
Okay, it helps streamline the process, helps avoid going down blind alleys, which you have to turn around from, rework, right? And I argued last time, and this is key, I argued about two constructs that I'm going to expect you to remember. One was, as time goes on, if you have a mistake that was made, say, early on in requirements, and you find it at later points, the amount of work or cost, however you want to sort of quantify it, over as time goes on, it tends to go up exponentially because there's more and more work that has to be thrown away. More and more requirements have to be revised, design documents that have to be revised, code that has to be revised, thrown away, replaced, tests that have to be revised, and build scripts potentially, etc. Lots of work that has to be thrown out. And once you start getting to deployment, and it's out there on users' machines, or it's in embedded systems, or what have you, that's when costs tend to explode. Okay? So that was one thing I introduced last time. The second thing I introduced was the iron triangle. Can anyone remember what are the vertices of the iron triangle?
Money, time, and quality.
Good. Money, time, and quality or scope. I mean, people define it a little bit different, but basically it has to do with value delivered, right? And what's the idea behind the iron triangle? Take two. Yeah. Getting all three is hard. It's really hard. So getting the program to come in within the desired time, within the desired budget, and with as good a quality and scope as you're hoping. And you can try to squeeze one of these down by trading off the others, but getting all three right is challenging. And I argued that in this case, requirements helps all three. Getting requirements right helps all three. Why is that? Why does it help time? Everyone's clear on what needs to be done. They're pulling in the same direction, and there's less misunderstandings there. Also, if you don't have time to do it right, you don't have time to do it wrong. I mean, you don't have time to throw things away and do it over, and that can really kill you for time. Bugs can kill you for time. You don't want to be in that position where you show the stakeholder a demo, you're really proud of it, and they say, that isn't what I wanted. That's not what I wanted. I wanted this other thing. That kills time. And, going back and reworking that. Not only the demo, but the code behind the demo, the test, etc. Right? Helps in the dollars front. I mean, after all, you spend dollars to have people developing code, and if there you have to take longer amounts to develop the code. If you're paying a contractor, minimum of $75 an hour for consulting these days, something like that. You're going to be paying more if they have to throw stuff away. I remember one consultant, 25 years ago, I was dealing with who was just in a dandy position. He had a project that was estimated to be a 2-month project. Come in and design a system like this and deliver on it. And it turned into a 2.5-year position for him. He was making money hand over fist. It was probably originally going to be, maybe $10,000 to $15,000, and it probably turned into $400,000 contract or something like that. Largely because the requirements were not pinned down, and it it became just an ongoing sort of revisions, and this isn't clear, and that's not clear, and I did this, now I have to throw it away. But yeah, I mean, he had a long-term employment situation that was much more stable than he thought. The worst thing to trade off, as we'll see, is quality and scope. And this is the easiest one, perhaps, to tweak. You say, well, we don't have time to test that well. We don't have time to do those peer reviews. This is it's due too soon. We can, cut corners with this. We don't have to handle the general case. Let's just force it. Let's put in a kludge, and it comes back and bites you. Extra time to debug, extra time to test because the tests aren't converging. Often it turns into a big mess, unhappy stakeholders, etc. So the iron triangle is really binding. Good. Now, as I said, I mean, it turns out requirements gathering or requirements elicitation is often really, really a hard thing, and it's key. If you look at the reasons things fail, this is one of the big reasons that they fail. And it's a lot easier to build a program if the requirements are clear than if it isn't. It's easier to get where you're going if you know where you're trying to go, right? So it helps along a lot of different avenues, and I won't go into it again too much here, except it's to say that it's arguably the most important thing. Now, one of the reasons why is very relevant to this class. Let's take each of the projects, okay, in turn. There's a project involving bed management, right? Right? Bed manager, yeah? With Alan McLean, yeah? There's a project that's going to involve the idea of this sort of clinical record associated with Jenny Basra and stuff. There's one for this collaborative software. Now, each of those areas, we're dealing with a specialized area, right? You're building it, even for a collaborative software, you may talk with me about it. And sure, I'm a software engineer and so on. I can communicate to you more clearly there. But I'm also speaking about things where most of you in this team have not directly seen yourselves, like building up these sort of diagrams. You haven't spent, a couple of years of your life building up these diagrams. So when I say, well, I need it to be like this or that, you have to kind of interpret my words in terms of your understanding. From Dr. Basran or from Alan McLean, he may throw out words here and there, bed, or ward, or resident, or something. And these things have very particular meaning that won't be obvious to you. This is, you might say, well, we have a bunch of weird projects here. It's not weird. This is standard stuff. If you go out there, whether as a consultant, or if you're working in IT, or you're a software company, chances are you will be building software for people who spend their time doing other things than software development. And they will speak totally different languages than you. How many people here were in the internship program? Couple people? How many people have completed the internship? No one yet. No one yet, right? You go consider folks who've been in the internship program, and they go work for Cameco, or they go work for, I don't know if Skip the Dish is hiring these days, or they go work for ESTI, or they go work for the synchrotron, or they go work for International Road Dynamics, or whatever. Each of these places is really notable for having a line of business that you're unfamiliar with. Occasionally you might go to IBM or something, and then they're in a line of business that you have some familiarity with. But even there, you might be in an area like compilers that has its own specialized terminology you don't know much about. So the point is that very commonly, we as computer scientists are building software for non-computer scientists. 95% of the time. And those organizations, those individuals we're dealing with have their own language, their own understanding that's very rich. And we only understand a little bit of it. And we're trying to translate their needs into something we can understand. And often we do terribly at it if we aren't careful in our requirements. Okay? So in the user requirements, I noted last time that we have a lot of issues. One of them that was emphasized from someone over here was the issue of ambiguity. Now there is incompleteness. We don't capture certain requirements. We have simply left it out of our list. There's conflict. Different people in the that you're dealing with have different statements, or maybe sometimes they think of one thing and they forget, oh yeah, I agreed to that, so they state something different. Different levels of priority, right? I'll say X, Y, Z, and really, X is by far the most important. Y and Z are icing on the cake. In those cases where you forget things, misinterpret it. But I also said that there was this large class called derived requirement. Can anyone remind me what a derived requirement is? Key concept.
Requirements that we, as the people building the project, recognize that are there without being told by the stakeholders.
That's a very nice way of expressing it, Boris. And often you recognize they're there because you know something the stakeholder doesn't know about the, for example, state of technology, right? So again, if someone says, well, I want a system that does really accurate voice recognition for lectures. So while it's recording, it's transcribing and really high quality. And I want it to be using a common smartphone, so you can keep it in your pocket or something. You may analyze the situation, and you go and you look at voice recognition libraries, and you find that really, to get the level of accuracy they want, you need to go online to cloud-based services. And you're not going to do it on the phone because the phone computationally is not going to be able to do that without becoming so hot as to be unpleasant or drain the battery. So you have to go to cloud-based services, and that means connectivity. And so connectivity becomes a derived requirement. The fact that you have to use these services and they have a certain performance profile associated with them, that has to be factored into your derived requirements. The end user didn't request it. They just said, I want to be able to do this. But to deliver that functionality, given the state of the art, you have these extra requirements on it, right? It can't be below a certain level of Android for you to do this effectively, or these libraries are only available on these sort of iPhones or what have you. Okay, so often, ladies and gentlemen, derived requirements are some of the most key ones, and I gave some examples here, and these are posted to the website. Okay, now we also often make this distinction between functional requirements on the one hand and non-functional requirements. And really the difference here is it about the behavior of the software, or is it about other aspects of the software? Can anyone give me a non behavior related aspect of the software? So it's a non-functional requirement. Can anyone give one to me? It's not about how the software, like what dialog boxes it shows, what order those are in, what buttons it shows, where they're located on the screen. It's not about the order of the screens that you see. It's about something else. It's not so much about the direct function of it. It's instead about, for example, and I have non-functional requirements, performance, for example, is a foremost one. The reliability of the system, how often it goes down. Availability, how often it's available. How portable it is, right? So maybe maybe Alan McLean, for his management app, he needs this to run on iPhone, but it's important that it run on Android in the future. So there's some need for portability to be able to port it over, and a non-functional requirement like that may require quite some thinking in terms of the design of it. Scalability. This is often something end users don't think about. And I'll tell you, and mark my words, there's a lot of things these days that are easy to do at a first cut. What I mean by that is if you've got, let's say, a web app, or you've got something that that links up smartphones and web apps through web services or something. It's often not that difficult to come up with a system that works for a small number of clients. 10, 20, 50, maybe 100. Where it gets a lot trickier is when you're dealing with bursty numbers, like they're all hitting your server at once, or you're dealing with thousands or tens of thousands of clients. And I've seen small companies go under because they don't understand this distinction. They don't understand issues having to do with scalability. They think, well, okay, it's scaled to 100, and so we'll promise this other client we'll host this in the same basic way for 2,000, and it doesn't work. Things break. Why do things break in this way? I mean, after all, if it works for 100, shouldn't it work for 2,000, but just in a slowed down fashion? What happens when you start going, you take a system that's not designed well for it to scale up to large numbers? What goes wrong besides it just being slower? Slower is bad enough, right? People stop using it. That's bad enough. But it gets much worse than that. Why?
Requests might be timed out.
Yeah, timeout is a big reason for the request, for problems being emergent. So timeouts occur. Timeouts when it's connected to a database, and because the timeout hasn't been handled properly, the system doesn't function adequately. Another thing is, ladies and gentlemen, synchronization issues. It puts a premium on getting transactions right. How many people here have taken 355? Okay, how many people have completed 355? Okay, good. 355 was last semester? Is that right? Okay, good. It used to be second semester, so that's great. So did you talk at 355 about atomicity, acid properties, atomicity, concurrency, independence, durability when it comes to database systems? Okay, so you have this notion of a transaction. These things have to happen together. They either both happen or they don't, or it's as if neither happens, right? So it's like ordering a book on Amazon. Either it arranges to send me the book and it debits my money, or neither happens. You don't want to be in a situation where it debits my money, I don't get the book, or be in a situation where I get the book. Well, okay, maybe you want to be in a situation where you get the book, but they don't get the money. For them, that's not acceptable, right? So the point is, you want systems that are transactional, that hold together. And often, when things get really slow, that's where, if it's not properly built transactionally, the gaps show. Because while you're in the middle of charging this person for their order, someone else grabs that book. And by the time you charge it, that book's no longer available. And then you can't ship it to them in the promised time. And then things go bad. So it really puts a premium on getting the transactions right, and transactions at locking cost, and it gets very slow. So the point is, bugs come out that wouldn't have come out otherwise. Bugs come out in galore. In galore. Sorry, they come out galore. Doesn't quite compute. They come out in spades. That's better. When things get slow. Okay. So scalability is the big one. Users often aren't aware of it. Often new graduates aren't aware of it, and it will bite you big time if you don't account for it. So watch out. You too may be a fresh-faced undergrad. Thinks, you can create a system like this. It's not just about creating it so it works in small scale. It's really often scalability is where it's at to really deliver value on a large scale, and often it's a lot harder than you think, and it takes a lot longer, and it kills you in terms of the time for delivery. Okay, so let's talk about functional requirements here. So often we'll characterize these in a structured way. Okay, who is this delivering for? Sometimes it's obvious, certain type of end user, but sometimes there's multiple types of end users. Give me two types of end users that might be associated with many IT systems. Maybe even a system for collaborative software or something. There might be two types of end users that might be relevant. Well, one is administrators, who sort of can delete projects, or create projects or whatever. And another is sort of rank and file users. Similarly for a bed manager, right? Maybe there's an administrative interface which lets you say how many beds are in each ward or something like that. And then there's the rank and file users who use it, right? So you have to remember that when we're documenting requirements, there are these different types of users. It's not all just the user. And they need to be able to do X. That's what this requirement is saying. They shall be able to to request a bed, or shall be able to see the current status of the bed. And what's the object? Perhaps add a bed to a ward, for example, to a representation of a user or what have you. And then there's some qualifier, maybe associated with performance or quality, or associated with some sort of conditions under which it occurs, conditions under which it's possible, as long as all the beds aren't already taken or something like that. And those may be conditions under which something happens, the results, what's done, and any further qualifiers for that. So we'll see some examples of this. Here, all network transmitted data that includes health information shall be encrypted with 128-bit RSA encryption. Okay. Until the camera app is either closed by the user or experiences as a timeout due to inactivity, the take photo button in the main IFB screen shall remain disabled. Requirement states what should be the case, and it leaves a fair bit of latitude about certain types of details. Exactly what algorithm or what library you're going to use to encrypt it or what have you, right? User indicates search and replace is needed. Notice this abstracts over what? A user indicates search and replace is needed. What is that abstracting over? What is that leaving out of the description?
How you're going to do it.
How? Yeah. Is it a button? Is it a menu item? Is it a double clicking? Tapping. Software responds by prompting for a search term and replacement text. Is that with a dialog box? Is it with a small box, docked at the bottom of your screen? Not so clear. User enters the text, indicates the software is to do a case-sensitive search. They indicate how. Is it a checkbox? Is it some sort of radio button or what have you? To replace all occurrences. So these are example sort of requirements statements. And there's actually an art to writing these things. I gave some examples, okay? Now, how many people in here to one of the 200 courses, 270 perhaps, or in 370 saw use cases? Okay, yeah, so that's pretty common. It sort of tells the story, it focuses on some user goal. Often those are articulated before functional requirements just to get your head around what's needed. And there's many components that can be incorporated in them, including postconditions and preconditions, etc. They can be understood by end users in many cases, or stakeholders, which is really valuable. And when there's a lot of user interaction involved, they can be quite useful. They often lead to things like this, these sort of requirements. And by the way, if you go to industry, you will find many projects have large, what are called SRSs. Anyone know that term? System requirement specifications. And they'll be filled with these sort of statements, meaning, that delineate sort of what the system shall maintain. And it's a contract of sorts between the sponsor, the client, the stakeholders, on the one hand, and the project team on the other. So use cases are great, but they have difficulty in certain cases, and they're certainly not cure-alls. They're not something you want to rely on for all of your documentation requirements by any means. But they help think through what are these requirements, what's needed here to some degree. Okay, So we talked about non-functional requirements and some of its pieces, and indirect requirements. Note some of these, and a lot of these things, I'm providing to you as resources so you can go back to them. These are the sort of things that you might want to provide for performance. Real-time guarantees. This will take no longer than 10 seconds to complete a search or what have you. The throughput, how many users can be handled, for example, per hour associated with it. The time it takes for something to load in, right? How soon does that screen showing the beds have to refresh, for example? And some end-to-end time for a transaction, for example. And there may be some requirements you put in place on the technical side the user doesn't care about directly, but have to do with the technical implementation. Okay, this is the main thing I want to get to, because I want to help. So much of these best practice, greatest hits, etc., is spent trying to get you the tools to not go down in flames in this class. I didn't used to do this, and projects would go down in flames a lot. I remember one year. How many people here are involved in CSSS? Okay. How many people have been to a CSSS event before? Okay, so CSSS used to have, I don't know, I think they still do, lockers and books over there, and things that people could borrow, I think, right? So this team, it was a team of, gosh, how big was it? 8 people or something like that. They set out to build a system that would support locker reservations. So the idea was we would put this over in the CSSS website, and people could use it to reserve lockers. And I think the further hope was, well, once they finish that functionality, to, reserve a locker, cancel a reservation, maybe administrator to cancel, clears them all, or what have you, and you associate with a name, etc. And then they'd get on to reserving books, right? So they went for the semester, team of about 8, bright people. Some of them are in industry doing quite well now. They didn't finish the locker reservation functionality. They didn't get to that point. They got bogged down in coordination issues and delivering it. I had the distinct impression that 2 really good people could probably deliver that project in the course of a semester. It actually would help if it's fewer number, because they don't have to deal with the coordination issues. Since that project especially, I've been trying to emphasize these best practices, and it's helped a lot. It hasn't prevented projects from going down in flames, but it's greatly reduced the likelihood, and often they at least know why they're going down in flames. That's maybe not that reassuring. Okay, so let's talk about some tips, right? Here's one of the best tips you can have. You go to meet a stakeholder. You have a meeting with the stakeholder. Stakeholder's using some words you're not sure you fully understand. Offer to repeat back what you've heard to them in your own words. Right? It provides that round trip, so you think you've heard it, and you try to express it to them in terms that you know, and not in their terms, because you could use those in a way that's so mysterious to you, in your own terms, and see what they say. You're putting yourself out there in a limb, but better now than discover it during a demo. That wasn't at all what I meant. Better to discover it now. So repeat back your understanding of the requirement to stakeholders. So they say something, and during the meeting, maybe even at the end of the meeting, but maybe shortly after it even, their statement, you repeat it back and say, I think that's what I heard, is that right? Very easy to do, and it can often be very helpful. Another one is ask them to repeat it in their own words, maybe several minutes later. Often they'll use somewhat different words, and you'll get a different side of it. I would strongly encourage you to do this. I would further suggest you have multiple people at that meeting. Why? Why not just the project manager? Project manager goes there as an executive and handles it all from your team. Why is that a problem?
Different people could hear different parts of it and
Totally.
understand it more.
Totally. Especially if you're hearing lots of jargon and so on. there may be aspects of jargon different people know. There may be, it may be that you're so tied up with trying to parse out things, you forget about other things they're saying. It's much more effective if multiple ears are hearing it. Often much more. And, after the meeting, they can debrief, they can jointly work up to write up a document, right? Okay, this is actually a really important one for many projects. This notion of traceability, okay? How many people have a sense of what traceability is when it comes to software? It's going to be a notable concept through the semester, and I'm going to introduce it here. The notion of traceability. Okay, the idea with traceability, ladies and gentlemen, is at a high level, we build our software projects out of pieces, out of chunks, and those pieces come in many forms of many artifacts. Okay, so we have, for example, give me some artifacts that you create in a software development project. There's one that's on the top of everyone's mind. It's close to many developers' heart. And what is that? What's our artifact? What sort of thing do you produce? Code. Code. So code modules. Great. What else is there that is produced and used often centrally within a good software engineering project? Design documents, yeah. And again, this is not having fun with pictures. This is about communicating what's the structure of the system to those who have to work within it. And often it's key for getting the vision that, say, a lead developer has over to other developers and to testers. What's another thing besides design documents that's produced? Unit tests. And in general, I'll abstract over the details of that, but I'll say test cases. It's a good point. Who mentioned that? Okay, name? Clinton. Clinton's on to a very important component of this. Test cases are often central to the success of a project, whether they're automated, manual, whether at the unit level, system level, testing multiple features, regression tests to make sure a bug, say, that was there before hasn't reemerged, or that a feature that was working before hasn't stopped working. Test cases are should be produced in spades by your project. Test cases. Other things?
A requirements document?
Yeah, requirements documents, another thing. Good. So requirements doc. Okay, others? How about I emphasize this part? Doc. What other sorts of docs might there be?
User manual?
Yeah, user manuals. Or, this day and age, could be online help systems, could be help systems built into the app, could be big user manuals still. Good. What other sorts of documentation might be there? Well, technical documentation, right? Design docs. So, say, design documents. Design docs, okay. We had that before, good. Man, I've seen that before. Okay, good. Like these, there's several other components as well, though, involving, for example, outcomes for peer reviews. So peer review checklists and products, etc. Okay. And then there's some things like test matrices that are going to be produced, and system flow paths too. So how does the system flow? System flow diagrams. Sort of what are the states of the system? How do you go from one page to another? Diagrams. Okay, system flow diagrams. How do you go, like what page is connected with what other page from one state of the system? How does it connect to other states? Now the deal here is that, folks, these are not solitudes. These are not independent things. How do they relate to another? Give me an example of how one of these might relate to another logically.
Test cases that test your code.
Yeah, you have test cases that test particular pieces of code. one way to think about, and trying to think about what are the linkages here is ask, suppose one of these things changed. What would it change? What other things would need to change? So give me another thing that might need to change.
You change requirements, you'd have to change design.
Good.
Change code.
And design leads to changes to code. Design also often leads to changes to test cases, right? To test that. And in fact, requirements docs often themselves lead to needs for certain acceptance tests. There's test cases that test certain requirements have been delivered on or what have you. This is test matrices. As the test cases change, the test matrices change. And also as the requirements, as the design docs change, the system flow diagram changes. The point is that there are linkages between these things. And one of the more important things you can do is to document these linkages. Why? Why would you document? Yeah, they're kind of interesting from a high level. What's
If
that?
someone makes a change, they know what else needs to change.
Yeah, that's exactly right. So suppose, you come back to your stakeholder and they say, after what I've seen, having seen it, I think we'll put aside this requirement that I mentioned earlier and we'll up this other requirement. Or I'd like to change what I requested earlier to have this instead. Now you've got to change the requirements doc. That may ripple through to this. Maybe the fact that they say, don't worry about that feature I said earlier that I talked about. Maybe that means certain things in the design doc that featured prominently in your coming plans are suddenly not needed. Or let's suppose there's a misunderstanding of requirements. That ripples through to several things, including design and code, that might have to be changed. And if you document these linkages, it becomes clear much faster what code needs to change, what does elements of the design, what test cases need to change because of that. Could you imagine this? Big problems in this class, big failure mode. Man, think about trying to emphasize how to avoid this, is the separation of testers from developers at a functional level. In other words, they don't speak well. They don't work together. Mark my words, project managers, mark my words, test leads, mark my words. Perhaps the most common pathology I see these days is the fact that you have a development team who's off and developing, and you have a test team that maybe is eager to test. Maybe they come up with some grand schemes for testing with test cases and so on, but the development team doesn't give them the code to test until late in the game, like 2 hours before it's due. And the test team is sitting there, frustrated, because they want to test this thing. They've been promised that they'll be given time to test it, but it slips, and it slips, and it slips. But worse than that, what often happens is that the test team doesn't have the knowledge how to really test it, because they haven't been told what's in the code base. People haven't checked in yet, and they don't know what's there, and they want to test it. They want to write these system-wide tests that call these methods in the code base to accomplish some system-wide functionality. They haven't been told what they are yet. That happens, and it's a big mess. Now, if you're using contract-based design, contract-based programming, you would have those contracts well ahead of time, and the test team could be anticipated. But even so, it's a bad situation. In fact, it's bad enough that it's been the number one thing on my mind. Bad. It's bad. And I've talked with previous team members about it, and it's a well-known issue. It's a well-known failure mode. How to prevent this? I remember one year they came up with some great test plans, really gold-plated, but they were never put into practice because they didn't have the code base, and it was totally disconnected from what the developers were doing. We're going to test this and this and this. Oh, great ideas, but they couldn't really act on it, and they were sidelined. It's not good for morale. So a couple ideas. Rotate test and development every other deliverable. You swap them back and forth. Another one. I've made this suggestion before, but I'm going to make this strongly. Pair up testers with corresponding developers. So the code is written next to a tester in many cases. As a result, the tester knows what's in that code. As a result, they can actually write tests against it, right? Maybe they're responsible for the use cases, moreover. This can at the least prevent a big fraction of your team from just sitting idle. When's the code going to be given to us? When are we going to get it? What's going to be in there? Oh, don't worry, you'll get it eventually. And again, 1 hour before the deliverable. You know, here's the code. Good luck. Throw it over the fence. Oh, well, we're still going to modify some things probably because this bug is still there. Good luck with your tests. Bad. So, pair programming, pair testing, buddy testing. One person tests, developer does tests for this other developer and vice versa. You have more developers but more testers also. The point is, you need to be able to attack that. And if you do have traceability, if you know what requirements affect, if you have requirements churn, and you will, almost it's very rare that we don't see some requirements change during the semester. Not because I'm being cruel, not because the stakeholders want to cackle. No, it's because their understanding changes and it becomes infeasible to deliver on all the requirements, and they're asked, well, could we do this instead? Could we do a stripped down requirement? Could we instead have it in this form than that form? Okay, so traceability, folks. Being able to know what the requirements affected in terms of your plans can help you turn around and adjust the new situation clearly. Prioritize the requirements, have clarity on sort of which of them are highest priorities. I think having some acceptance tests that will basically test the system is working in terms of being able to deliver on several clear requirements is very effective. That one's repeated here. Okay. Scrub things for ambiguous words if possible. But I think that's most of the issues. One of the issues here, though, having to do with testing is, look, testing tests different levels of a system depending on the level of the test. So unit tests basically test code implementation. It's the implementation of the system. Integration tests, detailed design. System-wide tests, high-level design and flow of the system. And acceptance tests, requirements. This is the ideal situation. I will require from you tests at several of these levels. At the least, you need unit tests. Who's normally responsible for these unit tests? The developers. System tests, by contrast, are typically written by testers. Okay? Now, again, you could have swapping going on. So who's a tester, who's a developer changes over time. Or you could have pairing going on. The point is a system test actually puts the system through its paces across multiple pieces of functionality. It's not just a test of a method. It's not just a test of a class. It's actually seeing how all these different pieces hang together. An integration test are testing like how A plays with B in a way pairwise. And finally, acceptance tests are often tests of several features that the user has mentioned, successive tests there. Okay, so what are some sources of error here? Well, ambiguity, I mentioned. Missing requirements. So under what case, suppose there's a requirement that's left out. The user hasn't mentioned it. Give me two extremely different cases, two totally different situations where a user may not mention a requirement, but it's there. They have this requirement. If you ask them, they'd say, yes, it's there, but they don't mention it. Give me two cases. They forget about it. It's not that important. It's not foremost in their mind. So, yeah, it's there, but, secondary, tertiary, what have you. Not a big deal. Give me another reason they don't mention it.
They don't realize it.
They don't realize it, and it may be so basic, so obvious from their perspective that they don't even mention it. This is a big issue if you're dealing with people from a different discipline, which almost all software is developed for. They assume, well, of course in banking you have to do an audit trail, right? If you have debits and credits for things and so on, of course it needs to be recorded, the exact time at which those occurred, have a complete history. I mean, that's basic to our institutions, to our reporting. So they just assume you know this. And they leave it out of their description. So you got to be very careful about this issue of missing requirements, and because of that, if you hear brief mention of something, or if you hear an allusion to something, but it hasn't been explicitly mentioned, asking more about it is valuable. Okay. Also there are these issues that I mentioned with non-functional requirements that will go missing. Okay, right. So normally, I'm not going to get into this this semester, but normally there's a whole series of documents that would be put together for many products that lead to successively clear visions of this product. And the first of them is like a one-page statement that gives a vision. And that's what you've gotten from many of your stakeholders here. It gives the scope of problem and very general statements for what's required. Going from that, often this goes to a vision statement, which gives the problem, but also a vision of a solution. Okay, a more detailed solution. What are the features of it? What are the sort of the scoping of successive releases? What's the rough schedule, etc. And then there's this whole scoping of requirements documents, of requirements specifications, the so-called SRSs that are very widespread in industry, where basically it unpacks in much more detail the features here. Okay, so again, this reminder about restating features is central. So I've given some examples here of the type of verbiage that would occur in different types of documents. I'm not going to require all this of you, all these different types of documents, but what I would like to see is some indication of requirements specification. Some indication that requirements are recorded, whether at this level or at the level of a vision statement. I want to be clear that you know sort of what the stakeholder has requested in crisp terms, so that you know where you're going with this. And the reason that you will want that is partially to satisfy that requirement for me, but mostly to pass it to the stakeholder and say, is this capturing what you want? Because if you don't get that confidence, you may be barking up the wrong tree. Okay? So any questions related to these issues on requirements? Nothing? Okay. So remember those tips, particularly repeating back to the user certain statements and making sure that they double check them before you capture those for your team as assumptions. Okay, so that was a bit on requirements, ladies and gentlemen. Okay, I'm going to now go and talk about a few other elements. One question that I got a question on, or one area where I got questions on, was related to risk management. And I have a section on risk management I'd like to talk a little bit more about, and I'm going to try to find the appropriate document here. So let's see. So risk management, yes. Okay, so okay, no, it's not that one. Okay, right. Tenable positions. Okay, that's part 2. So I need part 1 here. Okay. Pardon me while I get this in place here. Okay. Okay. best practices, part 1, version 2. Okay, yes. So it may be, no, it's not that. Okay, good. This is it, I think. Yes. Okay, risk management. Okay, I'm coming up short with this risk management slides at the moment, and I apologize for that. That's odd. The basic deal with risk management that you're going to be wanting to deal with is having a risk officer that is doing scanning for ongoing risks as they emerge. But you're going to, before you even begin that process, you want to do a baseline statement on sort of what risks exist. And the best way to do this is a risk brainstorm, where you take people within your team and you try to systematically talk about what risks do you anticipate for this project. And there's going to be a cataloging of the risks. And the key thing is to take that catalog and make sure that you have a sense of the relative prioritization of it, because there's going to be a lot of items there. And you got to be realistic about this. The goal is not to be exhaustive. The goal is to try to identify major risks that obtain. And those major risks may be components that are major because of one of two things. The first thing is that they are probable. Give me some risks that are quite probable in the course of your projects.
Somebody got sick.
Someone gets sick. Another one.
Somebody drops out.
Drops the course. Another one. People get overloaded with other classes, right?
Is compromised?
Sorry?
Code is compromised?
Code could be compromised. You mean in terms of a bug? Yeah, certainly that's going to occur. If it hasn't already. It's definitely going to occur. So good. So something could be a high risk because it's probable. Give me another reason it could be a high risk.
It has a really high impact.
Has a high impact. So really what we're considering here is two things. The impact of it if it occurs, contingent on it occurring, how bad is it? And the second thing is how likely is it, the probability. And the multiplication of these two is termed risk exposure associated with this. And what you're looking for is an enumeration of risks that have reasonably high risk exposure. So yes, you could sit back and laugh and say, yeah, there could be an earthquake, there could be a comet that hits class or whatever. But fundamentally, you're trying to find risks that have a decent exposure associated with them. And you want to catalog those, and you want to identify the top 10. Why? Well, it's hard to manage, a list of 100 risks. Top 10, you can keep on updating that. At least will get you thinking about the highest likelihood risks. Now, for these risks, you're going to want to then decide how you're going to handle them. Okay? And there's three major ways for, if you consider an additional case, that you may handle them. And I have slides on this. I think perversely there are already slides I've given to you, but for some reason I'm having trouble finding them. The first way is you'll simply accept the risk. You'll say, look, yeah, it can happen. We don't have a good way of dealing with it. We're going to just say, if that happens, we will bear with it. It's not worth trying to put in place a lot of mechanisms to get rid of it. Another one is you can avoid it. Sometimes you can avoid a risk entirely. Maybe it's a risk of instability of a new version of Chrome, or of this latest of an implementation, the latest release of the JVM on Android. And you'll just say, okay, we will avoid using Android versions above this certain level because we don't want to get into issues having to do with browser compatibility. An example here. There's some uncertainty now. I don't know how many of you follow Android development, But for years, people have counted on using a certain API in Android for tracing the URLs visited by a given user, and particularly in Chrome, which is the dominant browser. So 90% of Android users use Chrome. And for years, we've relied on a certain API for doing that. And it turns out that in version 6 and above, 6 is the latest, 6.x is, Google has deprecated that API. They said they're no longer going to support that. And there's a lot of scrambling going on right now online about how are we going to deal with this. There's a whole class of products involving security and sort of family safety issues and so on that rely on this URL functionality. And there's people sort of putting out their ideas for how to deal with it. You could do a workaround this way or this way, but no one's sure that those things are going to be maintained, that they're going to continue to work after the next release, because it's not promised by Google. So one way to avoid is to just say, our product is going to work on Android up to Android 5.x and not Android 6. We're not going that direction yet for the sake of the semester. No Android 6 compatibility. We're not going to get in the game of judging which of these are likely to continue to work, maybe break later in the semester. Okay? So acceptance, avoidance, but the two ones I want to emphasize the most are the most actionable ones. And this is what I'm going to look for you when you enumerate your risks. Contingency plans and mitigation measures. Anyone remember the distinction between these? I think I mentioned it earlier. So mitigation.
That's things to do to prevent the risk, I believe.
Okay, that's one type of mitigation. There's actually two types of mitigation, and they have to do with these two things here. So one thing is to really lower, so up front you take action. This is the key feature of mitigation. Right now you're taking action to lower the risk of it occurring, or to lower the impact if it occurs. Okay? Mitigation is upfront investment to put aside that risk. This could be doing a spike prototype, right? So that you check out these two technologies play well together. That, the Dalvik VM on Android works well with, Java 8 Lambda expressions or something like that. You can't find complete clarity on this, so you test it out. You take, a couple hours and you test it, it's throwaway code, but you secure confidence, yeah, this is going to work. Mitigation involves making that investment now. Putting in place now so that we're shielded. We lower its risk or we lower its impact if it occurs. Contingency plans, by contrast, are contingent. They're conditional. If it occurs, we'll do this. And the key thing is to come up with a contingency plan now so that you have clarity. If this happens, we'll do this. So let's take sickness. On your project. I can almost guarantee you someone will get sick in your projects during the semester. So give me a mitigation measure, something you could do, you could put in place effectively now that will lower, that will make you less exposed. It will lower your risk exposure to this.
As a career movie.
I'll probably lower it a little bit, but there's a good chance they won't get sick from someone else on the team. It won't be a hive of contagion, but so there's still a pretty big chance outside of your meetings that they might get sick there. So we'll lower it a bit, but I wouldn't bet on that for your major emphasis. Yeah.
You can have at least one backup person for each team.
Good.
In case someone.
So you have shadowing going on, or you have pair programming going on, or you have buddy testing going on. You write your code, I'll do the unit test for your code. You do the unit test for my code, and I write code against it, or what have you.
You could always just forbid all team members from going to public areas.
How do you get the
You could always do it. You could always be fooled into thinking it'll actually happen. So the point is to come up with some scheme now that will be effective in preventing it, right? So shadowing is a great one. Having peer reviews early on that document, so you spread knowledge about what's in there, what's in that code, how does it work. You know, each year from this class, I typically hear strong comments in the postmortems. If only we had done peer reviews earlier, because it really helped spreading knowledge around, helped get us on the same page of things. Do it. You might not think it's needed, do it. You can do it with requirements, you can do it with design docs, you can do it with plans for development, you can do it with test plans, all sorts of things. So do it, okay. So mitigation measures, upfront things. Give me a contingency plan type of thing. If someone gets sick, what do you do? Contingency plan wise, to shield yourself from that.
I've been on remote meetings, so no
Good.
one is sick.
Okay, so you'll say if someone's sick, you will put in place for each meeting a remote connection capability that will allow someone to connect remotely via Skype or Hangouts or FaceTime or whatever, right? How about another thing you could do if they get sick?
Always continue relaying information. For example, right now we're talking
Good.
about risk management, and
Yeah.
my risk manager isn't here, so I just told them that we're talking about risk management. You should watch the lectures online after class.
Good. That's right. So communication is part of it. Another thing. So you find someone sick. You get that email. You know, I've broken my leg. I'm currently in the ER, and they may fly me to Calgary for an MRI, and I'm in a bad way, and I'm not going to be able to make meetings. The doctor says I'm not going to be able to be up and about I'm going to be in traction for the next 3 weeks, what have you. What do you do in that case? Well, you have a clear sense of who might be the backup person, right? And you act on that. You send the mail as soon as that happens saying, okay, you are now the X. You are now the risk manager, or you are now the dev lead in this case. You have clarity on that. So you don't have to have a meeting, hastily assembled, what are we going to do, and who's going to be stepping in, and you have clarity because you pre-planned what to do if this happens. So I would expect, in terms of maturity for handling risk, that most of the risks you identify in your top 10 list, you have some contingency plan or mitigation plan. What are you going to do about it? And I will expect that list on each deliverable. Now, that top 10 list will evolve. Give me a case of one of these risks you've mentioned where it will definitely evolve. Risk of what? Dropping the class, right? There's a lot of drops early, not so many drops after drop date, right? So the point is, risks change. Technical risks disappear. You weren't sure if that would work out, it did. Or it didn't, and you know that. So the point is, I will expect from the risk manager an ongoing risk scanning where that person is looking either for new risks that are coming about, new types of risks, or risks that were identified previously and are actually materializing. In other words, they're coming about, they're actually coming to play. So either a new type of risk or a risk that was identified earlier that in fact is coming to happen. That's what I expect that risk officer to be keeping track of. And to do that well, they will often need to talk with other members of the team to find out what they see in the trenches. Because often the risk manager will not have the pulse on the risks that are occurring throughout the team. Okay? So they will want to be in an ongoing touch, asking people, what are there any things you're worried about? Asking the devs, asking the testers, asking the folks involved in triage or what have you, so that they receive clarity. Okay? So those are some comments on risk management. I do have slides in this. I think I've given them to you already. I apologize for not finding them there, but I'll make sure they're on the website in some form. Okay?